Hello and welcome to my channel. In this math video tutorial, we are going to solve more problems on Principle of Mathematical Induction, PMI, Principles of Mathematical Induction. So if you've not subscribed to this channel, please hit the subscribe button and please turn on the notification so that you get notified when I upload new video, and like this video as we're solving along. All right, so we have established from the initial video I've posted. I'm going to drop the link to that video so that you can be able to watch and have more foundation on this problem. All right, so we established 3 steps in solving problems that has to do with principles of mathematical induction. So in the first step, we say that we are going to show that n equal to 1 is true. So if we make n equal to 1 true, so at this point you can see that we have 1 square plus 2 square plus 3 square up to n square is equal to the right hand side. We have n into n plus 1 into 2n plus 1 all over 6 is true for all positive integers n. So what do we need to do at this point? Wherever we see n, we have to substitute 1. So because of the square, we have 1 square equals, so we have 1 here into 1 plus 1 into 2 multiplied by 1 plus 1, and the whole of this is going to divide by 6. All right, so what do we have? Of course, 1 squared is the same thing as 1 times 1, and the result is 1. On the right hand side, we have 1 plus 1, that is 2, and then 2 times 1, that is also 2. On this bracket, we have 2 times 1 here to be 2, and 2 plus 1, 3. So the 2 we have here multiplied by 3, that will give us 6. And then we have 6 divided by 6, and the result to this will be 1. All right, you can see that the left hand side, 1 squared is 1, is equal to the right hand side. Since the left hand side is equal to right hand side, then n equal to 1 is true for all positive integers of n. All right, then let's look into the second step. The step 2 is about assumption. We're going to assume that n equal to k is true. So what do we do at that point? Let's make use of this statement. So here we have 1 squared plus 2 squared plus 3 squared plus up to n squared. In this position of n, we'll have to replace it with k squared. All right, which is equals, what do we have next? On the right hand side, we'll replace the n we have for k into k plus 1 into here 2 multiplied by k, so we have 2k plus 1. The whole of this is going to divide by 6. All right, so what do we need to do at this point? We just have to leave it like this, and because we are making an assumption, let's assume n equal to k. So we substitute the value for the n. All right, and then we have this. So n is assumed true, n equal to k is assumed true, so leave it that way. So step 3 is built upon step 2. That means from the assumption that we've made above, we're going to show that n equal to k plus 1 is true. And of course, show here means prove. So how do we prove this? We have to bring up this expression, which is 1 squared plus 2 squared plus 3 squared plus dot 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 up to k squared plus, of course, this point, we're having n equal to k plus 1, so it will increase from k squared into k plus 1 all squared. All right, this will be equals, of course, the right hand side from the origin. Anywhere you see n, just substitute it with k plus 1. So here we have k plus 1, into, what's the next thing we have there? K plus 1, and then we still have 2 into k plus 1, all right, plus 1. The reason for which you need to cover this in a bracket, you have to close it in a bracket, is because 2, we need to have access to this. But if you leave it without brackets, 2 will only influence this k without affecting 1, and that will not be correct. All right, all this will be divided by 6. So what do we need to do at this point? We want to prove that this left hand side is equal to the right hand side. So that means from this point, you can see from here to this point has the whole of this. So in place of this 1 up to this position of k, we'll represent it or replace it with the whole of the expression we have on the right hand side from step 2. So we have k into k plus 1 into 2k plus 1 all over 6. All right, plus we have this one to be k plus 1 all squared equals, then everything we're having here, which is k plus 1 into k plus 2 into, so here we have to expand this. We have 2k, k, 2 times k is 2k, 2 times 1. So that 2 is going to distribute those values there. We have 2 here plus 1 all over 6. Right, moving forward. So at this point, we can observe that we have here to be k plus 1 all squared, and we have the denominator here to be 6. Here to be 6. We want to make this to look like these other ones. So let me use another method, like just make here over 1. So it appears to be a fraction in the shape of fraction, the way these ones are. So at this point, we could just look for the LCM. The LCM of the left hand side, the denominators. The LCM of 6 and 1 is 6. 6 divided by 6 is 1. And 1 times everything you have in here is the same thing you're having, which is k into k plus 1 into 2k plus 1. Right? Plus 6 divided by 1 is 6. And 6 multiplied by this is the same thing as 6 into k plus 1 all squared. All right, so this is equals whatever you're having on the right hand side, which is k plus 1 into k plus 2 into 2k. Here we have plus 3 all over 6. And this right hand side looks balanced already. So let's look into working on this left hand side so that we arrive at exactly what we're having at the right hand side. So when we're able to achieve that, then it means we've proven it. So let's do that quickly. So what do we do from this point? The next thing we're going to do is to work on this left hand side. So from the left hand side, what do we have there? We have k into k plus 1 into k plus 2 and into 2k plus 1 plus 6 into k plus 1 all squared and then all over 6. So what do we need to do at that point? We observe that things are common here. K plus 1 is common here. We have k plus 1 here. We have k plus 1 here. Because k plus 1 is common, let's fetch it out. So we have k plus 1, and that is common to, what do we have next? We are having that if we pull out this from this position to here, what will be left is k into 2k plus 1. I hope that is clear. All right, so plus, if we pull this k plus 1 out, of course here k plus 1 squared means k plus 1 times k plus 1. So if you pull one of the k plus 1 out, what will be left here is 6 multiplied by k plus 1. I hope that makes a lot of sense to you. So we have to cover it and then divide it by 6. Again, divide everything by 6. So what is the next point here? It is also very important that you need to expand whatever it is you're having here, so I'll be able to arrive at some reasonable function. So we have k plus 1 into k times 2k, that will give us 2k squared, plus k times 1, that will be k, plus 6 times k, that will be 6k, plus 6 times 1, that will be 6. All this will be divided by 6. So what is the next point? K plus 1 into, so here will be 2k squared. If you add up this, here we have invisible 1. 1 plus 6 will give us 7. Then k, that is k plus 6k will give us 7k plus 6. And this will divide by 6. So what is the next point here? This has formed a trinomial. This is the first term, second term, third term, trinomial, and okay, quadratic function in a more simpler way. And if we are to factorize this, we multiply this 2 by 6, that will be 12. So look for two numbers. When you multiply, it gives 12. When you add, it gives 7. Of course, the factor will be 4 and 3. So that way we have plus k plus 1 into, so we have 2k squared plus 4k plus 3k plus 6. All right, all over 6. Of course, if you observe critically, you see that 4k plus 3k will give us 7k. 6 is here, 2k is here. So if you group this, we have k plus 1 into, of course, you observe that if I group here, something will be common here, which is 2k. 2k is common. And if 2k is common here, what will be left if you remove 2k? That is just k. Plus here, 4k divided by 2k, we will simply just give you 2. Similarly, on this part, what is common here? You observe that 3 is common, plus 3. Factor out 3, what will be left is k plus 2. Because 3 times k is 3k, 3 times 2 is 6. All right? So at this point, you divide them by 6. What's the next point here? It's simple. You observe that we have k plus 1 left into, here we're having k plus 2. They are common, so you just have to pick one of the common, k plus 2. And then what will be left here is 2k plus 3. 2k plus 3 all over 6. So this is equal to what we have at the right hand side. Let's check. On the right hand side, we have k plus 1, k plus 2, 2k plus 3 all over 6, which is the same thing essentially we're having here, which is the same thing exactly, k plus 1, k plus 2, 2k plus 3 all over 6. So the left hand side, since the left hand side is equal to the right hand side, since the left hand side is equal to the right hand side, then k n equal to k plus 1 is true for all positive integers of n. So I hope this helps you, and then if you found this video helpful, please hit the subscribe button, like this video, and share. Thank you for watching Instructor Lesson Online Tutorials.